Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Anwar bin Yahya. Let me talk to you about the introduction of this project. DC motors are designed for use in industrial and commercial applications such as the pump and blower, material handling, system and gear drive, and adjustable speed drive. Okay, the motor are used to give rotary speed and position to various electromechanical system. Okay, the purpose of developing a control system is to enabling control since it has parameter turning difficulties, non-linear, poor stability, and imprecise control. Okay, now in this project, the main task is to control the speed of the DC motor. If the speed is equal to the reference signal, it can be concluded that the signal controller is successful to controlling the speed of the system becomes stable. There are four types of controllers considered, namely PID controller, state feedback controllers, fuzzy controller, and another one is fuzzy PID controller. Okay, the performance of the controller in controlling the system of DC motor is evaluated via computer simulation using MATLAB and Simulink platform. Okay, the objective of this project to analyze the stability, steady state, error, and transient response of control system by using appropriate method. Second, demonstrate analysis and design of physical system using time and frequency response method to the practical application in the control system. And the last, execute problem solving method and verify the concept convert in basic control system via hand calculation and simulation in computer aided software in the group project. Okay, now scope of study. The work undertaken in this project is limited to the following aspect. First, the complete mathematical model of the DC motor speed controller. And the second, simulation work using MATLAB and Simulink platform as a platform. Okay, thank you. That's all from me, Khairul Anwar.
Good evening, Professor Madya Dr. Badrul. My name is Sukowe. I would like to present my part, that is chapter 2. The topic is mathematical modeling of the system. This chapter conduct two sessions. The first session is a review on the relevant works. Then the first is the DC motor is one of the first machine device to convert electrical power into mechanical power motor. The DC motor uses electricity and a magnetic field to produce torque, which causes it to turn. It requires two magnets of opposite polarity and an electrical coil which acts as an electromagnet. The repellent and attractive electromagnetic force of the magnet provide the torque that causes the motor to turn. It also consists of one set of coils called armature winding inside a set of permanent magnets called the stator. Applying a voltage to the coil produces a torque in the armature, resulting in motion. This is the principle of operation of a DC motor. Then the second session is review on system component. First is brush on DC motor. The brush of DC motor are made with carbon. The brush are used to relay the current from external circuit to the rotating commutator from readings. The second is amateur reading. The amateur readings is handle or transform power, carry the load currents. It handle alternating current only is eliminated to reduce loss plus its rating is equal to the rating of our machine. Amateur currents depends on the type of load. That's all for my part. Yes, thank you.
Hello, I'm Tam. Now I will explain our chapter 3, the theoretical calculations of the transfer function. First, I will do the open loop. At the very beginning of this chapter, we will need to define the physical relationship of this DC motor. First, there will be two relations related to the voltage, and then three relations related to the torque. And then there is three equations we need to be applied. First, the Kirchhoff voltage law, and then the D'Alembert principle, and then the Kirchhoff current law. And then we can know that from the Kirchhoff current law, we can know that the I is equal throughout the experiment. And then, so we can apply to this equation of motion by comparing the voltage and the torque together. And then we should take the Laplace transform into this equation, and then we will get some JMS like this, the Laplace transform. And then next, by using these equation we can result in the transfer function by using the substitution method or the simultaneous method. And then we can get our GS, the omega S over the voltage input S, where is the KT over JMS plus BM over LS plus RA. And this is the block diagram for the open loop DC motor. And then we should do with the closed loop. The closed loop transfer function is quite similar to the open loop, in which that there is only one thing to be different, is that it could be a VB. There is a VB equal to KB omega. And then the compatibility equation and the equilibrium equation is all the same, except there is a VB there. So this could be last to result in the different Laplace transform, which could be you can see in this the transfer function, the GS, the omega S over V input S. There is a KT times KB here. So this induces that this reverse function in this. The block diagram for the closed loop is shown below. And then the next part will be the chapter 4. We will show you how the closed loop and the open loop will be functioned in the MATLAB. Thanks.
Salam sejahtera, Professor Madya Dr. Badrul. My name is Fong, and now I will take part in chapter 4. The title is Computational Analysis by Using MATLAB. So, what is MATLAB? MATLAB is a computer software to simulate the performance of control system in the case of continuous time and discrete time, between continuous and discrete time. And now, for our experiment, we have two, which is closed loop and open loop, for our DC motor design. So first of all, we need to find the transverse function and the block diagram of each loop, in closed loop and different loop. Closed loop and open loop, these two loops has two different transverse functions. So the purpose is to see and determine the difference between frequency and step response. So by using the MATLAB software, we plot 4 graphs, which is loop locus, plot, Nyquist, and step response. And also, in addition, we add a PID controller into the closed loop system. This is because to see the frequency response between controller and without controller. As a result, we get more stable and less time error in the controller, in adding the controller in the closed loop system, and rather than without the controller. So thank you. That's for my part.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Karun Nasbi Hamdani will present about the conclusion. As we know, our project is to analyze the stability, steady state error and transition response of control system using appropriate methods. Next, demonstrate analysis and design of physical system using time and frequency response methods to the practical application in control system. Lastly, execute problem solving methods and verify the concept covered in basic control system via hand calculation and simulation in computer aided software in group project. In this section, we use MATLAB software by apply transfer function to get 5 types of graph for both closed loop and open loop system, which first step response, bot plot, root locus, nucleus, and step response with PI controller which is specified to closed loop only. There is no big difference in terms of shape of graph for both closed and open loop except for nucleus graph. For the open loop, we can see the graph is oval shape, but the closed loop is side heart shape. For this project, we also have some problem. For an example, all of us is new in using MATLAB software, so it's difficult for us to apply the transfer function into the software. So it takes much time, but finally we success to get the exact result. So lastly, we can say that our project is success because all of the value and the graph are same as we expected from the first we start our project. So next is recommendation. We have 2 recommendations. First is we recommend that change the value of RPM to higher, then find the voltage for the future research. Second is instead of find the exact effect of loading, we also recommend that find the performance of the motor without any load. Thank you. That's all from me.